So in this problem, I am being told to use analytic methods. That means I got to figure it out with algebra and pencil and paper, not the calculator, to find the extreme values of the function on the interval provided. So here's the interval provided right there. And I would actually prefer to write this in interval notation. So x going from 0 to 3 inclusive. That's why I use the brackets. And I'm also supposed to identify critical points that are not stationary points. So although they gave me the interval here, I still would like to check for the domain of this function, just to make sure there's nothing in that interval that will that shouldn't be in the domain. So this is a logarithm, and I know that the argument of any logarithm, the argument of a logarithm, has to be greater than 0. So I'm going to put x plus 1 greater than 0. So x has to be greater than -1. Well, I don't really have anything to worry about because I'm not looking at anything less than -1. That was the interval that they gave me. So, but I'll just write that here. That was the domain of that problem. I know that logarithmic functions look like this. Like a parent function of a logarithmic function looks like that. And I know that the domain is that it can't be less than 0. I know that the end behavior of the function is -infinity to infinity. But again, I'm restricted to a particular interval here, so my end behavior isn't really going to matter that much for this graph. So once I've determined the domain and the end behavior of the graph, if I can do that, I need to start working on the problem. I need to find the derivative. So h prime of x, well, I have a logarithm there, natural logarithm, so the derivative of that would be 1 over the argument times the derivative of the inside. Well, the derivative of the inside is 1. So really, my derivative of this is 1 over x plus 1. And once I found the derivative, I want to look at it again and find out, well, what is the domain of the derivative? Well, I have a denominator here, so I know that my denominator, x plus 1, cannot be equal to 0. So x cannot be equal to -1. But again, I don't really need to worry about it here because it's not in my interval. So looking at my derivative, h prime of x, I want to find my critical points. And my critical points are where the derivative either equals 0 or is undefined. Well, there is no place where this is going to be equal to 0. I have a 1 in my numerator. There's no way I can make my derivative equal to 0. It is undefined, I know, at -1, but that is outside of the interval that I've been given. So I have no critical points, and if I have no critical points, I also have no stationary points. So next thing I need to do is we'll look at what are the end points of this function. Well, I've been given the end points. One endpoint is 0, and another endpoint is 3. So I need to know, well, what are the values of this function at those endpoints? So I'm looking at the function now, the values of the function right here. So I want to know h of 1, and that would be, let's look again, the logarithm of 1 plus 1, so natural logarithm of 1 plus 1. And I want to know h of 3, which would be the natural logarithm of 3 plus 1. So this is ln 2, and this is ln 4. So I have the points on my function, 1 ln 2 and 3 ln 4. And those points are inclusive because my domain here was inclusive of those points, brackets. stop, I made a mistake, so bear with me here. This really should be h of 0, because my farthest left number wasn't 1, it was 0. So then this becomes 0 plus 1. This becomes ln 1. And of course, the natural logarithm of 1 is the point 0, because we know that all logarithmic functions have the point 1, 0. So if I have the point 1, I have the point 0. So, so these are my values here, and I'm trying, and they exist. I don't have anything in between that is a critical point. So the extrema have to either be at critical points or at the end points. Well, this one here is my minimum because my y value is 0, and this one here is my maximum. Well, I don't know exactly what ln 4 is, but I know that it's greater than 0. So that is the answer to this problem, and we answered the other section about there are no stationary points, critical points that are not stationary points, because there are no critical points in this function at all.